No, no. The next content is chapter number 3, unit 3. So let me find out. Yes, the title of unit 3 is gas formation reactions. It's a gas formation reaction and oxidation numbers. So basically before we go to anywhere, we have to do is identify the Lorry-Bronsted acid and base in a reaction, write the equations for Bronsted and Lorry acid-base reactions, identify common acid-base reactions in which a gas is formed, and write equations for this. Thank you. Arrhenius definition is an acid is any substance that contains the H plus ion in concentration in an aqueous solution. And a base is a substance that increases the OH minus ion concentration in an aqueous solution. These are some of the common acids and the common ions associated with them. You can look at it, have a look at it, and then remember them because you will need them, especially when you know that some of them may be strong or weak. On the other hand, the Bronsted-Lowry definition of an acid is a compound that donates a proton to another species in an aqueous solution. And a base is a substance that accepts a proton in an aqueous solution. Therefore, because one ion gives a proton to another and the other one accepts it, in such type of reactions, we get two conjugate pairs which differ by just a proton. For example, in the above equation, Hx plus H2O, we see that Hx and X minus differ by a proton, and therefore Hx is the acid and X minus is the conjugate base. Similarly, look at water. H2O has 2 hydrogens, but H3O plus has 3 hydrogens, and therefore H3O plus is the conjugate acid of the base H2O. Why is H2O base? Because it accepted a proton. And another example shown below is that of ammonia in water. When we dissolve ammonia in water, it accepts the proton and becomes NH4. And therefore, NH4, when you look at the NH4 is the acid and NH3 is the base. And remember, when you are comparing them, all elements must be the same in the acid and base, and they must just differ by a proton. Now, some of the characteristics of acids and bases: any species that increases the concentration of H plus ion in solution ionizes in aqueous solution to form the H plus ion. H plus ion is just a proton. Acids are called as proton donors. A base is a species that increases the concentration of OH minus ion in solution, ionizes aqueous solution to form the OH minus ion. Bases are called as proton acceptors. Now you can identify in this which is the acid and what is the definition of a strong acid. A strong acid completely dissociates in water. If you see here, HCl gives all its hydrogen proton to H3O plus and Cl minus. On the other hand, when we look at weak acids, they do not completely ionize, only a part of it ionizes, and so we consider it as a weak ion. Now the strength, acid and base strength. Strong acids dissociate completely in water. Weak acids dissociate partially. Strong bases completely dissociate in water, and weak bases partially dissociate in water. Weak acid, anything that is not strong. Very important. Since weak acids ionize to such a small extent, the molecular species predominates. For example, acetic acid, the formula is HC2H3O2. And it is this H in front that is the acid part. Other non-metallic oxides can form acids in aqueous solutions. For example, carbon dioxide, when dissolved in water, forms sodium bicarbonic acid. Same for sulfur trioxide. Sulfur trioxide, when it reacts with water, it forms H2SO4. Both gases come from the burning of fossil fuels. Basic metal oxides form bases in aqueous solutions. They react with water to produce the hydroxide OH minus ion. As an example, you can see calcium hydroxide reacts with water to form calcium hydroxide. Acidic oxide, non-metallic oxide, can form acids in solution. Carbon dioxide plus H2O give carbonic acid. Sulfur trioxide plus water gives us sulfuric acid. Here are the chart again of some of the different types of weak and strong acids. Now, polyprotic acids. Polyprotic acids means acids which have more than one hydrogen. So monoprotic is HCl, HNO3. Diprotic, 2 hydrogens, is H2SO4, H2CO3. Triprotic is phosphoric acid and citric acid. The formula is given. Whenever an acid and base react together, you get salt and water. This is a type of metathesis reaction. What is the driving force behind this particular reaction? The driving force is the formation of water. And then we know that HCl is strong. It ionizes completely. NaOH is strong. It will completely ionize. NaCl is a salt which completely dissolves in water and therefore ionizes, leaving us only HOH, which is the net ionic reaction. Now, here are some questions for you to answer, so just go ahead, answer it, and get an idea of the concept, how you can detect an acid or base when the formulas are given. Now we come to the acid-base reactions, Prosted-Lowry, acid-base reactions. And here also you have that a molecular reaction is shown, HBr plus KOH gives you KBr plus H2O. So an acid is HA, a base is MOH, Ma is the salt, and HOH is the water, and generally written as H2O. And so when we write the net ionic reaction, we know that all sodium salts are water soluble. The acid also breaks up in solution. Water itself does not dissociate, and so the net reaction is H plus AQ plus OH minus AQ gives you water, H2O liquid. Strong acid plus strong base reactions are known as neutralization reactions. The net ionic equation will always be H3O plus plus OH minus, giving you 2H2O. The driving force in such reactions is the formation of water, a weak electrolyte. And this applies to all reactions of strong acids and strong bases. Now, what happens when you have a weak acid and a strong base? In that case, the weak acid does not ionize fully. So we write its formula down fully and then add the H. Remove the H from the acid to form water, and the base is left behind of the acetate ion. Gas-forming reactions, a metal carbonate, a hydrogen carbonate plus acid gives you metal, salt, carbon dioxide, and water. A metal sulfide plus acid will give a salt and hydrogen sulfide gas. And a metal sulfide plus acid will give a metal salt plus the corresponding sulfur dioxide and water. Ammonium salt, when it reacts with a strong base, produces ammonium gas and water. So these are some of the characteristic reactions that you have to know. Metal carbonates, salts, react with acids to produce metal salt, water, and carbon dioxide. So all carbonates, metals carbonates, when treated with acids, will always produce carbonic acid, H2CO3, which breaks down to give you H2O plus CO2. And if similarly, bicarbonates will give the same thing, carbon dioxide plus water. Metals, sodium, potassium, cesium, etc., that is in the same group, react very vigorously with water. And therefore, they are usually kept under kerosene. Metals and acids, some metals will react vigorously with acid solutions, others take some time or need warming. Reactions with formation of a gas, citric acid plus sodium bicarbonate. Reaction occurs when an Alka-Seltzer tablet is added to a glass of water. In ionic equations, gases are kept together. Most common is the formation of carbon dioxide. So all metal carbonates and bicarbonates react with acids to produce carbonic acid. Carbonic acid then rapidly decomposes to produce carbon dioxide and water. Show the reaction of calcium carbonate with hydrochloric acid. And these are some of the reactions that are given so that you can practice with them. And this is just a statement, study it. And this is a self-study. Beyond this are all self-study questions. So please check it and we complete the PowerPoint presentation. I'm going to stop.